my name is Will, and this is Crazy Talk Analytics. And this is going to be a relatively short video, as I'm short on time, so I don't know if that's going to make people happy, likely. But what we're going to do here in this video is we're going to create a function that returns a column index, so you aren't dependent on fixed column orders. And I read that pretty much verbatim. I started freeform and then kind of realized I'm reading this word for word as I just typed it, right? So it makes sense. But we're not going to get into the loan object, and there's a whole bunch of other things that we're going to do in between, which is why I kind of spaced that out. But this is a very, very useful function that we're going to create, and I'll kind of go over the implications after we go over our words of warning. So words of warning, not too applicable here. This isn't going to be a 5-minute video or anything like that. I don't think we can cover the topic that quick, although it would be great if I could. But just do note that a lot of this still applies. But I'm looking at less than 20 minutes from now for the video. Hopefully less than that. It depends on how long it takes to wrap it up. And let's go back over to our ITPs. And yeah, so actually let's jump straight to the loan summary, right? So we already explained what we're going to talk about. So let's say what we mean, or show what we mean. I have this loan summary table, and it's a true to form table up here, as we can see. And I have columns: loan name, principal, rate, and term. And what I'd like to be able to do is, say, instead of creating a VBA sub-procedure or some code that's dependent on a loan name being in the first column, I want to make it to where, regardless of what column this value is in, I can retrieve that and look it up. There's what it really kind of it irks me a bit. It drives me a little crazy. It pushes my buttons. It grates my gears or grinds my gears. All of the above. When people create code which is for this automation purpose, but they then tell you they have, in order to use this macro that I've created, the columns have to be in this order. And then they also sometimes hit you with, you have to use these column names. So there's a lot of conditions that are met. We're not going to tackle that second one, the having to use that column's names, but that is something that we can address as well. Right now we're just going to address the column ordering aspect. So if I wanted to check loan name right now, let's take a look at the code that we actually have. I think I can do these side by side, right? Yeah. All right. I think it is, here we go. So I'm actually just referencing, so we're sorting through this and we're looking for, let me slide this in a bit because we don't need that much space here. I'm not going to mess up things too much, so I'm going to see if I can, it doesn't automatically make this one larger though. Okay, so what we're doing with this first code, this auto loan code, is we're iterating over all of the rows, and then we're looking in that row's cell 1, which is the loan name. Now, cell 1, it's not an arbitrary value. It's a excuse me. We selected cell 1 because we know for a fact that when we designed this, that's where we put the loan name. But when somebody's reading this code, they might not know what does cell 1 mean. Why are we looking here at this? There's really nothing in here unless we actually put some comment in that says iterate through rows until you find the loan name that matches in cell 1. We can kind of infer it too from this line. If WS name, if the worksheet name equals R cells 1, then that might work. But what would be great is if there was a way that we can actually replace this 1 with whatever column index corresponds to its location. Let me before we get into this a little bit more, let me demonstrate one other concept, which I kind of messed up yesterday when I was trying this. I want to say what column is, because this could trip you up when you're working on this. Hold on one second again. Okay, let's say I want to know what column the active cell I have right now is in. So this is what we would look at as range B5 or cell B5. So we could say debug.print, and I'm going to use the property active cell, and we're going to say address, and we get B5. Now I'm going to, instead of print the address, I'm going to print active cell dot column, and we get column 2. So it's the second column of the worksheet, but it is as you can see here in our code, the first column of the range in that list object. And the reason that is because when we are iterating over this row object, that row is a row specifically in, well, actually it's this one, right? That row is a row specifically in that data body range, and that data body range is confined by this. So the column number is actually relative based on what you're looking at. If you're looking at sort of this restricted area, or if you're not, and you're just returning the column of a cell, and regardless, you're going to get it in respect to that whole worksheet. So that could give you unanticipated sort of results. So what do we want to do? And I'm talking a lot for a quick video. Hold on. My throat's really bothering me today. So what do we want to do? Well, what we want to do, very simply put, is we want to search a specific range of cells. So it could be an actual range of cells, it could be an array, it could be whatever concept or construct we want. In this case, we're just going to keep it to a range of cells. So we're going to look at each cell in there, and then we're going to return a value that sort of like matches that relative column index, or just, you can even look at it almost as cells. And let's create a function. Let's just create a function, and then we'll go from there. So we'll insert module, and what we're gonna call this mod. We're gonna call this mod functions, because this is where we're gonna keep a lot of our general purpose functions. And interesting fact, functions that you write in a module like this can be usable in your workbook as well. So it's kind of really neat. Actually, let's just get rid of this. All right, so let's call this function getColumn, GET underscore COL for getColumn. So we're going to call this, it's going to be a public function, and a function, the primary difference between a function and a subprocedure is they both technically can return values, but functions are designed to return values. Subprocedures are really executing a process or a procedure, lines of script, whereas a function, you should be focused on returning something. So we're going to say get, I'm going to leave the underscore off. I've seen before where people use underscore to represent spaces in methods or subprocedures, but they don't do that for a function. And it's, I don't know, there's some merit to that, I guess. And I'm going to, so this is where we're going to pass our parameters now. So getColumn is going to be the function name. Parentheses to start that, because remember, everything, whether it's a procedure, a function, or whatever, will have these parentheses. And typically, we don't use them unless we're passing an argument. And the argument that we need to pass in there is the range that we're going to be looking in. And in this example, this range is cells B4 to E4, or more specifically, it is our header range, but it's still a range. So I'm going to call this RNG as range, and then we have a value that we want to look up, or a column or a header. Let's call it a header, right? Or yeah, let's value, right? This gives us a little bit more flexibility. Let's say VAL as I guess we could put it in here as a variant. I didn't want to at first, but as I'm thinking about it, this probably gives us the most flexibility. And what do we want to return this as? Well, we're going to return it as, it could be a long number type is exceptionally long, but integers go up to like 256,000-ish. So I think we're fine with calling this an integer. I can't imagine we're going to have columns or ranges that go with more than like 256,000 columns. If that's the case, then maybe you want to change that data type. So now what we're going to do is we're going to indent make this code a little easier to read. So we are going to iterate through each value. So what we'll do is we'll use the C variable for that. And I'm going to say C as integer. And I'm using C to represent column. It's just, I like these single letter variables as iterators. I is the most common, but in this case, or in some cases, I like to say, well, if I'm iterating over rows, I'm going to use R. If I'm iterating over columns, I'll use C. I is always a great go-to as well. So a lot of times things in code are indexed at 0. But then when we're looking at, which means the first number in that series is a 0, but when we're looking at Excel objects, a lot of them, because they acknowledge that that object physically exists, I guess, I don't know why, but they'll start at 1 instead. So what we're going to do is we're going to do a for loop. We're going to say for C equals 1. So there's different ways to do for loops, right? You could do a for each loop, or you could say for when this variable equals this value. But we need to assign a limit. So if you say for each column, or for each range object in a column, you don't need to necessarily set a limit, because you're going to be iterating over every range item that there is. But if we're going to say for C equals the number 1, we're going to need to say, well, where does that number end? So we're going to say for C equals 1 and 2, and then we're going to say RNG, which is our range variable, and then we're going to say columns, which is a collection of however many columns are in that range, and then we're going to say count. In this case, it's going to count the columns and return the number 4. So this is essentially reading for C equals 1 to 4. And always, always, always end your loop. We're going to say next C. So it'll go through and it'll perform the code as many times as it needs to. Now, what are we going to do each time C equals that value? So here we're going to say C equals 1, C equals 2, C equals 3, C equals 4. Well, what we're going to do is we're simply going to evaluate the value in that cell, in that range, and then we're going to check it against the value that we're passing. So we could say if RNG dot, so I'm going to use cells reference just because it's going to get me what I need, and I know that. The row is always going to be row 1. So this is what I was just alluding to, in the fact that the first row in a range is not 0, like the first default index in an array is 0. The first row in a range is 1. And since we're typically only passing a 1-row range as a header area that you're going to be looking up, or whatever it is you're looking up, the row index will always be 1. And that's an example of that relative row index, right? So it's row 1 of that range. It's not row 1 of your worksheet. And then the column index is going to be our C. So that's this variable right here. And that's one of the reasons I decided to use C, was to make it more relatable. So if RNG in dot cells 1C, and by the way, whenever I do this, we're inferring that we're pulling the value. You can leave that off because those are kind of the same thing. But if you really wanted to be technically correct here, you would say equals value for clarity. And that's the value within that cell. So if that equals VAL, which is the variable, I have 2 mouses and I have two mice, and I keep grabbing the wrong one. So if this variable, or if this value equals our variable VAL, which we're passing, then what we're going to do, we're going to go ahead and put an end if. So again, there's many different ways that you can write these if statements. For simplicity, I'm saying if ending on then, and then we're going to end up with a end if block. So our code that's in between is what gets executed if that condition is met. And it just keeps it simple. So what we're going to do here is say C, well actually get column equals C, and then we're going to say exit function. So it's actually relatively simple. I'm probably making it a lot longer and more complicated than it needs to be. So for C equals 1 to columns count 1, 2, 3, 4, if the corresponding row 1 column equal to C, the value in that cell equals the value that we're passing, then we're going to assign the get column value, which is the function name. So that's how we actually return the value of C, which is an integer. And that integer is going to be 1 to 256,000 or so. And then we exit the function. Exit stage left or stage right. If not, then we go to the next C, and then we go to the next C, and then we go to the next C. So what's going to happen is if you don't actually find the value, you're just not going to get that returned. It will always return something. It just won't necessarily return what you're looking for. So let's try this. Let's say debug.print, and we're going to say get column. There we go. It actually auto completed that for me because it knew we wanted it. RNG is a range. We're going to say sheet. We're going to pass it directly. So we could say range B4 to E4, but we're just going to use sheet loans dot list objects TBL, which is what we've been working with. And we could mix it up depending on how much time I have here. And then, so we accessing this object, and now we will say, well, actually, let me do this even easier. All right. I don't know, I'm short on time when I'm doing this. So we're going to say set LO equals, as if we're actually sheet loans dot list objects and then so now we're going to say debug.print get column, and we are going to say our range is going to be LO dot this might not work in series, unfortunately. Alright, so we'll go back to what I was doing. But this is essentially what we're going to be plugging in here. And we're going to say header row range, and then the value we're looking for is our loan name. And it is in cell 1. So now what happens if I take this and I move it to, I can't do that. Well, actually, let's just switch it to rate right now. So instead of loan name, I want rate. And let's clear this value, because I'm just about out of time. It says rate is in column 3. So this is returning a number relative to the position of that column. And then that number you can then feed into your formula here. So we can then, instead of saying r.cells1, we would then be able to say get column, and I'm going to undo this for purpose of picking up on the next video. But then we could say, so it's a specific range now, which would be R, and our value would be, and that's because R is That's because R is a range over here, right? And that's what we did, is we set R as a range. So we can pass that as a range, and the variable, not the variable, the value, not the variable, the value loan name. And then this will essentially return the number 1. You can also assign that number to a variable and check it that way, such as C. Again, we can use C as that variable. So I'm just going to go ahead and undo that. We'll incorporate it when we start in the next video. But this is how you create a handy function that really has multiple uses. So you can use this in a lot of different code. And this will allow you to no longer be dependent on the fixed position of a column. You just use that function in your formulas, in your codes, in your code. You can tell when I'm just about done with the video. You use this function to return the corresponding result of that column in your code, and you should be great. It should work perfectly. Now what happens, real quick, we'll just do this if that value is not in there, because you need to account for it. Let's say we're looking for rater instead of rate, and we get the number 0. So all you have to do is build into your code, what are we going to do if it returns 0 instead of an expected number? That means that value is not found. You can do some error handling or some conditional statements, etc. There's a lot of ways you can do that. So that's not something we're going to get into right now. But with that, I leave you, and I have to start my work day. So thank you very much for watching.